what about when you have a term that's split between two brackets? Well, like I said before, you want to get it in a term that's easy to differentiate. So what we're going to do is get a term for f of x that's easy to differentiate. So f of x is equal to, we'll just multiply out these brackets. So x, so that's the way I do it. I go x squared plus 5x, there you go, minus 3x minus 15. So let's put this together as one term. So go x squared, so and 5x minus 3x is going to be 2x plus 2x minus 15. What's going to happen here when we try to do f dash x, or find the derivative? So we'll start off here. For f dash x should be pretty easy. So pretty easy, x squared, we already know that's 2x, and then 2x multiplied by, so you multiply the power 1, then decrease that power, so that's going to be 0. So that's just 2. And then what about this 15? Well, the 15 doesn't have any kind of x term, so you can kind of think of it as being independent of x, or doesn't have anything to do with x. So how does it change with x? It's not actually affected by how x changes in f of x at all. So it actually just becomes 0. So our final answer is 2x plus 2. What about this term here? Again, it's kind of an extension of multiplying out. So we want to get it in a nice term that's easy to use. F of x equals, and before we can say this is x to the half, and then we have x minus 2. So what's this going to equal? So you should remember that that's x to the 1, and when you're multiplying powers, they just act as if they're adding. So we have x to the power of a half add 2 is the same as 3 over 2. And then when we multiply this over, that just becomes minus 2x to the half. All right, so this is a form that's pretty easy to differentiate. So we'll go on to differentiate here. So f dash x. So we'll start off with multiplying down by this power. So that's 3 over 2x minus 1. So that's back to 1 over 2. Then here we have minus 2x to the half. So half times 2 to the x the half minus 1. So what does this now become? So that just stays the same as 3 over 2 x to the 1 over 2, and this half times 1 is just 1, so that's just x, and that goes from a positive half minus 1 to a negative half. So we can rewrite this again to a similar form to the beginning with square roots in there. So this just becomes 3 root x over 2 minus 1 over the square root of x, because that's, it's a root and it's a negative, so it needs to go on the bottom. And that there is our final answer. All right, we'll go on to do another example. Okay, just here. So what if you want to find the derivative of f of x when it looks like this? Again, it's really the similar idea. You want to get f of x in the simplest form to differentiate as possible. So let's just start off by simplifying this by putting every term over x. So x squared over x minus 3x over 5. 3x over x plus 5 over x So already we can see that some of these x's were cancelled. So that x cancels with that cancels with that cancels with that cancels with that. So that's already made this problem quite a bit easier. So we'll rewrite it out again. So now this equals x minus 3 even. X minus 3 plus 5 over x. Now, again, this can go one stage further in being simplified. So that just becomes x minus 3 plus 5 to the x minus 1. Okay, so now, I know it seems like a lot of steps, but it's so much easier to get it in a form that is simpler to use. We're going to start to differentiate. So f dash x equals x to the power of 1 times 1 decrease the power. It just becomes 1. And then minus 3 doesn't have an x term, so that becomes 0. And then you have 5x to the minus 1. Okay, so minus 1 times 5 becomes minus 5. X, and this decreases, goes to minus 2. So our final answer is 1 minus 5 over x squared. Right, I hope that makes things a bit simpler. I think we've got one more example. Yeah,